Alright guys, so forgive the holding and the vibration apparatus here. I'm doing this with my phone. I don't have an actual regular camera. And some things need a regular camera. But this is the control box out of the ambulance that I pulled out the other day. And I really like the design of how it is. And we're going to talk about how it's put together and how it's designed, what I like about it, what I don't like about it, and then we may go ahead and go through and design a new circuit board on the Easy EDA CAD system. I've been sitting there learning it and getting to understand this is a really basic board. There should be only 2 layers in this board. And what's 2 layers? It means I have a front layer and a back layer. Back here there's a layer of traces. And all circuit boards really are is a fiberglass core with copper on the outside that has been etched to make these little wire traces here. So instead of having wires going to each component, you have everything kind of nice and organized and in its place and easy to understand if you're looking at it. So anyhow, we're going to start with this coil up here, and as you can see, these are standard automotive relays. You can actually pull one off. It's part of the thing I kind of like about this design, if I can get it off. Maybe. Hang on. Okay. You just pull it off. It's a standard automotive relay. I like how they did it. I double checked it, and it's standard. There's another one that has a different number combinations, but you can see the numbers on there. That tells you what goes to what. Normally you just have a little schematic. Oh, there it is. There's a schematic on the side that tells you what number does what. And that's all this does. And this is a socket to replace it with. This is the output wire here. And this is the fuse. It's normally automotive. These are resettable breaker fuses. I like this because if they pop, you can still see that they are popped. I'm going to do some design changes when I build my own. Just so it makes it easier to tell when these pops. And I'm still not entirely sure my design's going to work. But anyhow, let's get back to it. So what we had is we had a wire up here coming down, and it was a solid heavy gauge wire. And this is supply. This is power coming in. And it goes all the way down this. And this side's power coming in. But when you look right there, there's a break. And this is another one. And it actually had the wire going to this circuit down here. Let's see if I can get it right. This circuit down here was going through this DC switch, power switch, and it had a ground lead. This is what turned this thing on to allow power to flow between these 2 poles by running this to a ground. So it's a negative switch. When you have something that comes in and you have the power go through it and you have to run it to the ground to turn it on. So if this ever shorted out against the frame, it'd turn the switch on. It wouldn't turn it off. That's what a negative switch does. And most this up here is also negative switched, as far as I could tell. My design is going to have it do it either way. But basically, so if one of these went out, because DC relays tend to go out because they're a mechanical device, and mechanicals tend to go out more than electrical. But they have these easy sockets to replace, and you can just replace them on there. They also have these really nice circuit breakers, they're called. They're DC circuit breakers, 10 amp. They sit in a regular automotive fuse style here. You could put a regular fuse in there if you wanted a blade fuse, but I kind of like these. The bus had automatic resettable breakers. This has a manual resettable, so you have to push the button whenever it trips. It keeps you in there and it looks. These things right here are the inputs to the relays here. This is what tells the relays what to do. This ran to various components on either side. This is I'm thinking this is a maintenance thing. This is to come in here and do maintenance. You just pull it out if, say, you left the back doors open. You have the dome light with side door. Or you have, where was it? Rear loading with rear doors. These are the lights that come on when you open the back door. And you just pull this one off. This is a jumper cable. You pull it off and it allows it to stop working if you're doing maintenance. However, whenever I was doing maintenance, I didn't look at this thing closely. I pulled the relay or pulled the breaker over here, and this is, see how it says rear load right here? This is what this relay is going to. This light, this LED comes on whenever this one's engaged. So if you turn this on, this light comes on. And let's see. But there are some various other things. I'm not quite sure what this is doing. This could have been an alternate control thing. These are the compartment doors inputs. So when the door pan the door was open, it turned on the switch, which turned these on, which turned on the inside door light. They do it this way to save on wiring weight, so the control wires don't have to be so big, and you can run really big, massive wires over there. And it gives you a certain protection because you're not running it all through the component. So you can run a small light component, light low amperage component, which saves a little money, and run it through a relay and control it with a relay. And yeah. Anyhow, I really like the design of this. And you see right here how it comes in and drops down over there. That actually goes underneath. So let's see. Oh god, I can't get out. Anyhow, you're gonna have to take my word for it. We'll go through the design thing, but it goes underneath and goes over to the control circuit on this. And there's a little where is it? There's a resistor underneath there that runs this LED here. I also like that they have screw terminals here, so you can put the wire on, you can put a ring on it, so even if it vibrates loose, it's not going to come off. I'm going to try to repeat that. I don't know if I'm going to repeat that completely. Now, this wire down here, these are all just power wires. These are power, they're always on. It's part of the always on system. You have always on, and then you have switched power systems when you build out these things. But you remember seeing all that wirings and breakers and relays in there? It looks like they had a problem and they just threw more relays in to fix it. The reason I know they had a problem is if you look right here, let's see if we can get the angle right. See how this thing moves? That should not move. Basically, they had a too big a gauge wire on here and a lot of vibration has broke the solder joint. And let's see if we can get it where we can see. It's not really bright enough in here to see. That controls all these breakers right here and whatever went out on it, and probably as I was going down the road it worked intermittently. I mean, it wouldn't come on or it would come on, but it just depends, and they couldn't probably find it. Also tells me because of the wiring they had in there, they either could not fix the problem or they never pulled this board out to check the board, because if they did, they would have found the problem. Well, there you go. Now you can see some light down in there. But they didn't do that, so, and it's probably part of the reason I got it so cheap is because it had some weird electrical issues going on. Anyhow, this is the other side. Where are we at? This is the other side of that. You see how that is a bad solder joint. Let's see. See how you move it back and forth? That is actually not even an existent solder joint. I think they just didn't consider the vibrations of it when they designed it. I like the solid bus bar, but they would have been better running some wire jumpers in there to get the amperage they needed, and I think I'll fix that in the next one. This is the underside of the relays. These crosses here, right here, is all part of the relay. This is the back side of the fuse, so the fuse comes in here, and it comes over the fuse and comes in. This is the main power. This is one of the main inputs going to the output. This, and then this little side one is one of the coils here, and this side's the other coil. And let's see, oh, they ran those grounds, the LEDs difference. This is actually running from, no, it's ran right. This is the, whenever it has power connected to here, the switch that has a power, this is the output. This pulls off and runs to a resistor, through the resistor, and all the way through to ground. And my recording is going to stop on me here. But here's the other problem they had. Someone shorted out a wire and it destroyed a lead and turned it into a little mini fuse, which is also why another circuit probably doesn't work. So there's a few things going on in this circuit board. We're going to design our own. I really like this. It's always so satisfying. Okay, sorry. We ran out of speed there for a little while. Let's see, how's our power doing? And we're almost out of power. Anyhow, so we're going to design our own circuit board that's very similar to this. We're not going to use this array panel and have it done like that. We're going to use screw terminals. You can buy these boards online. They're anywhere from $85 to $250 for 6 of them. We're going to design our own through Easy EDA. Now look, here's that bad solder joint, and it's controlling all these fuses. There's a random jumper that they decided to make an alternate, and then this one's been touched up. A few of these have been actually touched up. That one's been touched up. That one looks original. This one's been touched up. You see, because all the extra solder on there, they're trying to make it more vibration proof. And this one's been touched up too. And it's not really good solders. You really should have that good wicking angle. You kind of see it here on this. See how it's just barely around it and wicks up? That's a good solder joint. But you gotta look at these things closely to see it. But you really see that bad solder joint. That's why if you have a weird electrical problem, you should pull everything out and not just check it. Because if there's testing it and it happened to be touching that, it'd work fine. But yeah, it's a good thing we pulled this out, and we're going to replace this all with new stuff and make the troubleshooting easier. We're not going to use a solid bar either. We're going to use some stranded wire because it can handle vibration. I'm also probably going to end up reusing a lot of the AC lines because they used a really high quality stranded wire, and they had a ton of it in there, and I can reuse that as much as I can. So, and it's really good wire. Anyhow, I actually have the thing tore apart right now. I'm going to actually put this in the new electrical compartment and hook the positive up this, and this is going to be my ground in the new electrical compartment. And we're going to make 2 of these. Right now, like I said, I'm still in the design thing. We're going to have one for bus systems, the ambulance automotive system, for anything I want to add, outside lights and anything like that. And we're going to have some way to tie them together, so if we're driving down the road, I think I'm going to still pull all my light systems, my power system from the lithium setup. It should have more than enough power to do it, and we'll just have a way to charge it when the rig's running. Probably an automatic charger, and then we'll have the control wires coming from the DC system. So we'll have 2 separate DC systems along with a AC system running it and the solar system. So we'll have a good design down whenever we do finally build it up. And long-term goal is to digitalize this and make this where it's remote, and I can see everything remotely too. So we'll do that later on. But I just wanted to bring that in so you guys could see. Alright, y'all. Let's start out with a simple one-circuit solution. Sorry, this may sound a little bit strange. This is my second time recording this. I lost my audio whenever I recorded the first time. Learning everything on computer and getting the best shot possible. So I'm using the Windows 10 free screen capture program to do this. Anyhow, welcome to my channel. If you're new to 360 Gal's channel or my channel, most of it's been recorded with 360 up until this point. However, 360 does not work for everything, so we're going to do a regular video. Mainly, we're going to talk about a relay box, a relay terminal like that was very similar to the design that was in the vehicle, and I like the design. However, I have decided to design more options into it, and we're going to go through the schematic layout of it. This is how everything is connected. Usually when you do these things, you breadboard them out first to make sure everything works, but this is a pretty simple design, so I shouldn't have a problem breadboarding it out. Mainly as I don't have the components right now, and it's actually going to be easier to have it printed up and sent to me and put it together on that. And worst case scenario is I had to tweak it and have more circuit boards printed up and sent to me. The circuit boards are around $2 for 10 of them, and it's $20 to get them shipped. So yeah, it's cheaper to have them made than it is to be shipped, but it takes a little while to get here. But I've been working on this for like 2 weeks now, trying to learn the program and learning all this doing. So let's start. What is this circuit for? It is a relay circuit with automotive relay in it, and it's designed to turn a small power into a large power without actually directly going through it. I can also hook it up in such a way that I can run it on and off from a different battery source than what it's actually controlling. So it gives me options. It also will be easily to replace components that go out. The main components that will go out is the relay itself, because it's a electrical mechanical device, and they don't last forever. A solid state would be better, but they're kind of expensive and it's hard to find reliable ones. This one will have a socket where I can just pull it out and replace it with a standard automotive relay that I can get from any auto store while I'm out traveling. This part right here also will have the option to replace. However, I will have a resettable version. This is a blade style automotive fuse, and if it becomes a pinch, you can come in there and replace it with anything, or you can just drop a jumper in there if you want to bypass it altogether. But this is my solution for creating a safe relay environment in my new RV, and it will give me options in the future. I also have plans in the future to maybe make it remote control, but that's not in this design, and we are not going to discuss that right now because the knowledge that goes with that has not been researched yet. But we are going to talk about the operation of this circuit. This circuit is designed in such a way that I can have a positive or a ground control the coil on this, or neither, or both. And it's also designed in such a way because the lead sides would be so big for running the power to 10 of these. I'm going to have 10 of these in parallel to each other, this independent. I'm going to run a power cable if I need it. There's a lot of ifs in this circuit because it's designed in such a way that I can basically change a couple jumper relays or pin headers. It's called breakaway headers with a what's it called? A header jumper type thing. So you can change how this circuit works just by changing a couple pin locations on it. It gives options for a lot of things, but the main reason is I want to be able to turn on a light and have a whole array of lights turning on. It takes a small power source and turns it into a big power source, and it can pull from a different battery system to turn on a different battery, something in a different battery system. Or I can have two different switches. I can have a switch that turns on and off my lights in the cab if I forget to turn them off in the back, or I can have an on and off switch hit by the door as you come in. That controls the same thing with this setup. Anyhow, let's start with how it works. Basic electricity, 12 volts wants to go to ground, and it'll take the easiest path possible. We make it do work in between. Losing my voice a little. Anyhow, so we're going to start up here. These two are large wire pads I pulled off the internet, but they had the basic idea. What I'm going to do is whenever I connect these all in an array together, whenever I have more than one, like all these down here, well, I'm just going to strip a wire and run it along there to give me the amperage rating that I need for all of them along here. This gives me a nice even way to hook it up without going insane. The trace leads that are required for an amperage of 30 amps times 10, 300 amps, it's just not feasible to do on a circuit board. So I'm going to have to drop in my own addition here. From here, I'm going to go to this. This is a screw terminal. Basically, you drop a screw with whatever you want in it. It gives me options to bypass this and have it be controlled by another like auxiliary system or something like that. It gives me more options in the long run. We go down here to a fuse. This is a regular blade style automotive fuse. This is the reason I went with this one is because I can order online and I can get the footprint for it from a schematic, and I don't have to do any special modifications. All it is really putting parts together. So being that this is a fuse, it may blow. I may not have a resettable fuse. It may be a regular fuse. Instead of paying the money for the lights that come on whenever you have a fuse like this or something like that, you can do a standard automotive fuse. It comes out here. This is the main power line right here. This is the main power line coming out. It goes over to the main, normally closed on it, but we're going to work our way over. So main power line comes out, it comes to a resistor, which slows down the flow of electricity, and it goes through an LED. Basically, the resistor here is to protect the LED, keeps it from going out. And the LED goes to ground. So basically what that means is, what is it? If this has power to it, which means the fuse is good, it means the LED is lit. So if the LED is lit, it means the fuse is good. If there is no LED on, it means the fuse is bad or something up here has gone wrong. This is kind of this is a quick look, tell you if the circuit's working right. And we'll go into this, but basically it goes to ground. Anyhow, so this also comes off, and this controls the 85 side of the coil. And due to some headers that I can put a jumper pin on either or, not both because it caused some weird issues, but say if I want to ground switch this, that means I run it to a switch and it pulls from the backside of the terminal and runs it to ground. I can have the jumper going across 2 and 3 on here, which allows it to pull power from the main line. Also will not operate if the fuse is blown, which is none of this will work without the fuse being in there. This is a safety thing, just an extra thing. So anyhow, it comes through here, goes through the jumper, and comes out, goes into the coil. Coil comes out, and from here you can choose which way you want the jumper to go. If you want the jumper just to go to ground, and you can wire it that way, that means this thing will probably be always engaged as long as there's power on this fuse. If you want to control it, ground switch it with the switch, you run it in here and jump the jumper between 2 and 1. You come out here and it comes to this screw terminals, which takes it out to the switch, which takes it to variable of power ground. Anyhow, I can also change it up and choose that I don't want to use this power and actually positive switch it by changing a jumper here and here. Or I can have them both coming from this location here and not even use the power ground. It's basically about giving me options of how I want to wire it in the system itself. It's kind of like a universal DC system. I don't actually know exactly how I'm going to run all my wires, so this gives me options in that, and it's easy to build it this way since I'm going to have it built anyhow custom for myself, and it works good for that. Anyhow, so let's come back to, say we don't have the switch on, the coil is inactive, the relay is off. So we come back to power, the main power line, it comes down here to 87, which is a switch inside a switch. It's electrical mechanical switch, and these things do go out. I do plan on putting a socket in here where I can replace the relay with any relay from any auto store. That's the whole design of this, is for easy convertibility and changeability and easy parts replacement of without worrying about where you are or where you got to have it shipped to or mailed to. We can go to any auto store and buy a relay and replace it. It's a good design. It's a good redundant design. Anyhow, so this 87 is normally open, meaning that when it's off, it is normally open. It means there's no contact there. Normally closed would be, when it's off, would be 87 up here and normally have content. And there's actually a reason I'm actually leaving this in there and leading it to an external source. There's always options in a relay. You can make it do kind of whatever you want. This will be a 12 volt system because it relays 12 volt. And this will be part of my house, my chassis system, and maybe a middle ground area there of what it will control. This gives me options so I don't have to run big wires to the switches and overload the switches. I'd run a little micro switch if I want, and it'll control it. And future plans is to figure out a way to run it from an Arduino or a Raspberry Pi or something along that line. But this is the power circuit that handles it. There'll have to be a whole nother circuit for that. But it's nice to have the design here and ready to do kind of thing whenever I'm ready. And anyhow, so the main thing is the main output is on 30. That's the relay pin 30. It's the one that can switch from either normally closed or normally open. We get to choose it. If we, for whatever reason, don't want to use positive power source, it's still going to be fused, but we can cut the wires going to the main power line and we can run whatever source we want up here. So we don't have to switch positive. This basically gives us option. Anyhow, let's say we engage the relay. This thing here, this little switch here, moves down here. You're going to have to visualize it. And it turns on and it connects the positive to 30. 30 goes out to whatever it needs, whatever work it needs to do back here, turning on the light, running backup lights, turning on off-road lights, turning on inside lights, turning on the rainbow lights, whatever you want. It's basically on-off switch and power. By coming out here, you see there's a little junction here, and there's a resistor here and another LED. This LED also goes to ground, so this will only work in a positive only state. If this is ground switch, this won't work. But in the positive only state, when this is engaged, this is on, this will turn on this LED and tell you that the relay is operating in the preferred method if you're using the preferred hookup method. Like I said, there's a lot of ifs and everything about this. This is a schematic design. It is cool, but let's see. Let's bring it back down here and bring it back into the regular thing. These are basically several little independent circuits with a safety fuse built in. I will have a bigger fuse for this wire going up. This is what keeps everything safe. This is why you should always use fuses and breakers or some sort of current controlling device for the wire size in your rig. This is how we prevent fires, one of the ways. So, and in the bus system, I just literally ran a large wire to switches and ran it back there. And yeah, it had systems that are good for it and not. But because it's aluminum and I kind of want to have some fun, and I'd like to make this more control over this circuit and do other things other than this, this is what I'm going to try to stick with. And it kind of saves me some money down the road. So let's look at the physical layout of the board of this. So I've already been designing it for a while. Basically, it's going to be set up like this. This is 3 of them I got, and I'll probably be doing more of them as I go. I haven't figured out the easy way to copy and paste and repeat the same circuit diagram on the same board. But basically, these are my leads coming in. This is my screw terminal. This is one side of the fuse. This is the other side of the fuse. And we go down main power to the lower one. Of course, this is the physical layout, not the schematic layout, so you have to do stuff differently. This is basically the terminal that plugs in. This is the alternate, and this is 30 that's going out, resistor LED. The jumper pins here that choose. And what my ideal layout of it is, all my outgoing lines are going to be coming off this way and going down, and coming off this side and going down, although I haven't built it. All my control lines are going to be coming out of the roof, or the top. It's where all my control lines go into, low voltage or low amperage control lines, high amperage coming down because they're going to be heavy. And right here in the middle is where my power cable is going to come in at. So I have the heavier lines the lower in it and the lighter lines up top. But yeah, so I'm going to sit down here and manually place all the lines, I guess. Yeah, manually place all the lines. Excuse me. Yeah. So I'm going to manually place all the lines. I'll put you guys in time lapse so you guys can watch and see this circuit board being built. The reason I'm using Easy EDA is because I don't believe they have a circuit size limit, and it's free, and I can team it up with LCSC parts, where I can have the physical dimensions of the parts. That's where I get these outlines. It's from this parts manufacturer that I'm going to buy from, but it should be good enough, and it basically saves me a whole bunch of CAD drawing to design each of the individual holes for what I got or what I'm getting from different locations. Saves me a little time, and I think I'll be able to do 3 10 relay boards for about $100. So I'm gonna have to solder it all up myself whenever I get it, but that's fine with me. That's kind of fun. And hopefully everything works, because I did not breadboard this out first. But we'll go from there. Let's adjust this up. And basically this will be working in such a way that I have first one will control this relay, second one will control this relay, third one, this one, and so on and so forth. And that's kind of how the board size is going to be based on how this all lays out. I might actually raise this up just a hair. And let's see. Give us 3 spaces, which I think 3 centimeters in between each one. I wish it snapped. I don't know how to make it snap. But yeah, the first one was the hardest because I had to figure out all the physical layout. The second one's a lot easier. Let's see. If we do this just right, look at the grids. It'll make it look somewhat professional and not like we did it with our mouse with, single hand and kind of thing. Let's see. I'm lining up the crosses with the crosses. There we go. And this LEDs, lining this up. That looks a little bit lower. Either way, it's not going to be perfect because, well, I don't touch perfectly with my hands. There we go. Oh no, I don't want to do that. I was actually editing this last night and I did something silly. I was trying to close out the screens up here and I accidentally deleted all my work I did. So this is all new work. Yay. And let's see. We want to drop this one in here, rotate it with the R key. Drop that here, drop the LED kind of right below this one. This is the one that the LED is actually triggering off of. Let's drop that in there and bring this a little bit farther this way. Same thing here. LED up. And I'm using through-hole components on this one. Ooh, that's not good. Yeah, that's okay. That's better. Through-hole components just because I'm used to working with that, and that actually works better. What was going on there is this positively was shorting out with that one, and we can't have that. And the blue lines is the back side of the board. And so we're doing a two-board layout or two-sided layout. So this is the back side of the board, so I can cross wires and everything else, just as long as they're not crossing with each other as they should be. And you can drop these little junctions in where it comes up, goes under, and then comes back up on the other side. And I'll be using that a lot for all these other feature ones. So anyhow, I'm gonna put you guys on time lapse. You guys can sit there and watch me do this for a while. And hopefully we can get our board designed and shipped off today. All in all, it's going to cost me close to $130 to design my own board to get 3 of these. But considering most of these, without the options that I got designed into, it's going to cost you $225 or more each. I still consider it a good value. So, alright, enjoy, sit.
you.